morning, everybody. Make sure you guys are getting this little warm up done. This is kind of a review of the last couple of classes. And just another reminder, if you're a senior, I sent you an email about your final. So if you're a senior, you should not be here. You should check your email. I sent a link for the final. So if you're a senior here, I did send an email to you detailing how to take your final and what that's going to look like. And if you have questions, you can just write me an email, okay? So if you're a senior, make sure that you guys should be taking the final right now. I sent you an email. Yep, I sent you an email. Check your email. Yep, absolutely. Please do, because you should be working on your final. Yep. Yep, take care. All right, guys, we're going to go over this warm up and take a look. Again, if you guys have questions as I'm going over it, please feel free to just pounce right in and ask. Again, if you are a senior, I sent you an email about instructions on what you're supposed to be doing right now, because right now is your final. So if you are a senior in here, make sure that you guys are checking your email, and you don't have to be in here right now. You guys can use this time to work on your final. Okay, so that's seniors only. All right, so taking a look at this problem. So we have a couple of, we have two different things, right? So the first one is what we did last class, and the area one is what we did from 2 classes ago. So for the volume, right, and we're going to talk about this today. So if it's if it's just a base and it's extended out, then it's just volume equals area of the base times the height, or bash. And that's, we're going to talk about bashing a little bit more today, right? Because yes, there's some sharp edges, but the surface of this is bashy. And we'll talk about the other one today, and that's going to be stabby. So, right, so we got bashy and stabby. So volume equals the area of the base, and we can't forget this, guys. The capital B is the area of the base, right? So this, the capital B, is we have to insert a formula. So it's area of the base. So I'm going to have volume equals, now the base here is a triangle, so it's going to be 1/2 the base of my triangle times the height. Okay, which is different than the height, that is the distance between the two bases. Okay, and I know that can be confusing, and that's why we got to work on that, right? The H in here represents the height of the triangle because it's the area of the triangle, whereas the H out here represents the height of the 3-dimensional shape, or the distance between the two bases. Okay. So what we're going to do is we're just, at this point, we're going to fill everything in. Notice how I'm going to have 3 different lengths in here. So if I have 3 different lengths, that means it's going to be a 3 dimensions. So I'm going to have 1/2. The base of my triangle is 8. The height of my triangle is 6. And then times the distance between the bases, which is 10. So I'm just going to grab a calculator and just do this all at once. So I'm going to have 0.5 times 8 times 6 times 10, and I get my volume equals 240 centimeters cubed, because I'm dealing with the 3rd dimension. That is, I have 3 one-dimensional things multiplied to get there, right? So it's the 3rd dimension. Wow, so that's what we did the last couple of classes. How do you guys feel about that? Does anybody have questions or comments? Does anybody, like, did I lose anybody? Because that's not what I'm trying to do. So please let me know if you guys have questions. Well, thank you for responding. I really appreciate that. Anybody else have any questions? So again, all of this stuff is going to be on your final, guys, right? So we got to make sure not only do we have the formulas, but we know how to use them, right? And we know that we replace the capital B with whatever base that we're looking at. Okay, this next one is a little bit more complicated. I think we've done this one before in class. Maybe it's slightly different numbers, but I wanted to see if you guys are picking up on this and are doing okay with this. So in this case, I have 1, 2, 3 shapes. Okay, so to find the total area, I'm going to have to find the area of these 3 shapes. So this one, it looks like it's a square, so it's 5 by 5 by 5. So my first shape is a half circle. Okay, so I'm going to find the area of a half circle. So that's going to be 1/2 pi r squared. Well, taking a look at this, right, it looks like this isn't my radius. It's the total distance across. That's my diameter, right? So my diameter is 5, which means my radius is going to be half of that. So it's going to be 1/2 pi and then half of my diameter. So how do we get this? Well, so squared, that's going to be 5 squared is 25, 2 squared is 4. And then 1/2 times 4, that's going to be 8. So I'm just going to go ahead and write this as 25/8 pi. And the reason why I keep it like that is there's no rounding, okay? So people always like, well, why would I ever use fractions? Well, we don't want to round, right? So I have an exact answer right there. Okay, so I did it squared. So 5/2 squared, that's just 5 times 5 on the top, 2 times 2 on the bottom, and then 1/2 times 25/4, you just go 2 times 4. That's 8. So 25/8 pi. So that's the area of my half circle. And again, if you guys have questions, it's better to ask them right away than it is to wait until the end. So if you guys have questions, go ahead and let me know. Okay. All right. Next up, we are going to take a look at the second shape, which is a square. Well, squares are just special rectangles. So that's going to be the area of my square is just going to be length times width. And since it's a square, they're the same, right? So that's 5 times 5, which is just 5 squared. Hence, we call it a square, right? That's where the name square comes from. So we're going to go 5 squared. That area of the square is going to be 25 centimeters squared. Oops, I didn't put units on this. Centimeters squared, right? And it's squared because we're talking about the second dimension. We're talking about the second dimension. So that's the second one. Then we're going to do the third one, and that's the area of a triangle. So the area of the triangle is 1/2 the base times the height. So the area of my triangle is going to be 1/2 7 times 5. Oh, that didn't make it nice, did it? Well, 7 times 5 is 35. So I can just leave the area of the triangle as 35 halves centimeters squared. And then again, no rounding. Now I know you can write that as a decimal without rounding, but the point is that as a fraction, I can just type these all into my calculator and not have to worry about did I round, did I do anything. Okay? And I'll show you what I mean in just a second. Because we're going to find the area total, and that's going to equal area of my first one plus area of my second one plus the area of my third one. So my area total is going to be approximately, and this is where I just add them all in. So I have 25/8 and then pi. Again, never approximate pi into your calculator. Always use the pi button on your calculator. And then plus, I got 25 as the triangle, and then 35 halves is the 25 was the square, 35 halves was the triangle. So I get about 52.32 centimeters squared. Okay, notice how my units here are squared, whereas when I did volume, my units was cubed because we're talking about different dimensions. Woo! That was quite a bit of math, huh? To start out the class. How are you guys doing with that? Does anybody have questions about what I did here? There is going to be something like this on your final where you have a composite shape that you're going to have to find the area. I mean, yeah, you could keep. So in general, if you're going to round, you just go all the way. That's what I would say. So would 40? So let's take a look. 45.625 pi. No, that would be a much bigger number, right? So 45.625 pi is 143. So that would be incorrect. So this would not be an answer. Way too big. Remember, pi is like 3.14. So that's like it's almost 3 times more than the answer we want. So 45.625 pi is not an answer. Right? If I wanted this with pi in it, I would divide by pi. So this would be approximately 16.65 pi. Okay. So if you wanted to do it that way, it would look like this. Which, again, It's not easy to do this with addition. So that's why I don't recommend doing this. You just have a calculator just tell you as a decimal, right? If you wanted an exact, then you could go from there. Okay, but to get this answer using algebra is actually a little bit complex, and I don't know if you guys have ever been taught to do that. So, and it's unnecessary for right now. Okay, so I'm glad that you brought that up. Okay, so if you're going to round as a decimal, just go all the way. Just go all the way. All right, let's get into, unless there's further questions, let's get into new material. Okay, so what are we talking about today? We're talking about 11.6 and 11.7, and we're talking about volume of pyramids and cones. Okay, so volume of pyramids and cones. Now, you might have heard me talk about bashing, right? But today, if you know about what a pyramid and cone are, maybe I should start there. So how do we draw a pyramid? So start with a triangle. Okay. Start with a triangle. And then we're going to go back like this. Now, we're not going to use parallel lines in this one. So this one's going to be a little bit different than our last one. So we're just going to go and bring that down here. And then we're going to do a 3D effect for the rest of it. Like that. Now, drawing pyramids, I think, is a little bit more difficult than drawing prisms. Okay, but this is, so this, notice how the base here is a rectangle. And then all of the sides on the top are triangles. Okay, so we got a rectangular base and all of the sides are triangles. Now, this could, right, we could change the base to be whatever we want, but of a pyramid, the sides are always going to be triangles, okay? So this one would be called a rectangular pyramid. Because the base is a rectangle, okay? So that is rectangular pyramid. Now, one thing I want you to notice, the difference between a pyramid and a prism, right? They're both P words, is that notice how the pyramid doesn't go to a rectangle. It goes to a point. Okay, and it's called the vertex. Okay. So this is going to be really important for us going forward because you're going to have to remember the difference between a pyramid and a prism, and the difference, guys, is going to be the point. And I'm going to say it once and we'll say it again, because a pyramid, you can stab someone with it. See? And you guys see where I'm getting bashed now? Because with pointy objects, you would puncture, right? You would stab. So a rectangular pyramid is a stabby, right? So if you can stab someone, not cut someone, stab someone. Okay, and yes, I know this is weird. Like, crap, why are you doing this? It's getting awfully violent. So again, right now we have prisms. You can bash someone with it. You're not going to puncture someone with a prism, right? You might cut someone, but you're not going to puncture. You're not going to stab. Okay, so pyramids, you can stab someone. Now, how do we do a cone? Well, a cone, surprisingly enough, we're also going to start with a triangle, but we're not going to draw the bottom. So you're going to start with a triangle, but don't connect the bottoms. Okay, so don't connect the bottoms of the triangle. And then what we're going to do is we're going to make a half circle in the front and then a dashed half circle in the back. And that's our cone. Okay, so the cone is a little bit easier to draw. All right, so this is a cone, and there isn't different types of cones, it's just a cone, because a cone has a circular base. So a cone is just a really special type of rectangular, of pyramid, right? Because it's, instead of a polygon base, it has a circular base, and so it adds curves to it. Okay, now also notice on a cone, right, we have a vertex at the top. So both of these have the ability to stab and puncture. And that's going to be important for my silly way of remembering how to do volume for these. Okay. So this is how I remember it. Okay. If you stab someone, so if you stab someone, they will lose 1/3 of their blood. Okay. Now you can quote me on this. Okay, it's just a creepy thing, but the weird things are the things that we remember, right? We never remember the boring things. It's always the weird things that stand out to us. So if you stab someone, they lose 1/3 of your blood. Now you might be like, Kreft, why are you doing this? Why are you being so creepy? Because the only other way of doing this requires calculus, and we don't have calculus yet. Okay, so the 1/3's not going to make sense unless you have calculus, and it's called something called the power rule, where you take the integral of area, and then you take the exponent and put it out in front. Okay, I know, right? So if you stab someone, you lose 1/3 of their blood, and trust me, guys, I've been teaching this for years, and this example is by far the one that students remember the most. Okay, so again, it's weird, so you're going to remember it. So if you stab someone, they will lose 1/3 of your blood. Okay, so what does this mean? So let's talk volume. Okay, so on one hand, we have objects that can bash. Okay, and then on the other hand, we have objects that can stab. Okay, so we're talking about bashing and stabbing. So in bashing, right, what are those shapes? So we have like a box. We have a cylinder. Okay, they're bashing shapes. Okay, notice how their surfaces are flat. Okay, a stabby shape is what we just talked about, like a pyramid or a cone. Okay, so notice the difference between them. We got bashy shapes and we got stabby shapes. Okay, stabby, bashy. I have this weird feeling that like an administrator is going to walk by at school and like see what we're doing and be like, what's Mr. Kreft doing? And they're going to be like, they're going to ask you and you're going to be like, oh, Kreft has always been a little bit different. All right, bash and stab. Okay, now the reason why I did the 1/3 blood, because volume for a bash is area of the base times the height, which is kind of like bash. You guys with me on that? So bash is volume equals area of the base times the height, whereas stab, and guys, this is the new one, if you stab someone, and let's see if you guys were paying attention in chat, how much blood is someone gonna lose? So in chat, you guys say this. There we go, 1/3. If you stab someone, it is 1/3 of their blood. See, it's silly, but it's effective. Okay, so that's the difference. If you bash someone, it's area of the base times the height. If you stab someone, it's 1/3 area of the base times your height. Now, for some of you, that's not going to be very satisfying. You're going to be like, where does the 1/3 come from? Well, it comes from calculus, like I said, and well, since we're just not there to do that calculus, you're just going to have to take me and my silly story about losing blood. Okay? Now, when I was in school, I had these plastic shapes that I could fill up with fluid, and I could show you that this is true, right? Like a science experiment. But that is all locked up in storage, and I don't have all of that, and I don't even know where that storage is. So in hindsight, I should have brought that home, and I'm a little sad that I didn't. So without being able to show you physically through science, then all we have is this really creepy story that you're probably going to remember for a long time and think Mr. Kraft is a little weird. But bash shapes, area of the base times the height, stab, 1/3 area of the base times the height. So let's do some examples of this, and I'll show you what I mean. Okay? So let's say we are going to find the volume of these. So this one is going to be a little bit difficult. Here we go. So we got boom, 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 boom. So I'm making a triangle with the hypotenuse is dashed. And then I'm going to go boom, boom, boom. So this is, we're going to call this 4 meters, 6 meters, and 9 meters. So I just started with a triangle with the hypotenuse as a dashed line. And then from where the 4 and 6 meet, I just went straight up and then connected the sides. Don't worry about your drawings, guys. They're just there to be a resource, right? We don't actually have to care about how good they look. Okay. All right. So the first thing we're going to notice here is this a bash or a stab? So it's a stab. So they're going to lose 1/3 of their blood. Okay, the next thing we have to figure out is what's the base? So this base is a triangle. Okay, do you guys see the triangle in the base? Here, what if I highlight this as blue? Okay, so that base is a triangle. So then I'm going to say, okay, the volume equals 1/3. The base is a triangle, so it's going to be 1/2 base times height of the triangle times the height of the pyramid. Okay. So I'm going to go ahead here. I'm going to plug things in. So I get volume equals 1/3. So it's 1/2 the base. It doesn't matter which one is the base of your triangle and which one's the height. See how it's multiplication? Order doesn't matter. So if you switch them, not a big deal. Okay, so I'm going to go 4 times 6. And then the height of the pyramid is 9. And then we have a fancy dancy calculator. So I'm going to go ahead and type those all in. So I have 1/3 times 1/2 times 4 times 6 times, oops, not divided, times 9. Okay, so 1/3 times 1/2 times 4 times 6 times 9. And I get my volume equals 36 meters cubed. Now I'm going to stop there for a second. Does anybody have questions about how I did that? So again, it's really the same stuff. The only difference is if you can stab someone with it, they lose 1/3 of their blood. That's it. That's the only difference. Okay, so stabby, we put in the 1/3. Okay. And that's a really good test, right? And remember, it's not cut, it's stab. Okay, so if you can stab, 1/3. Okay, and if you can remember that, you'll probably remember that for the rest of your life. Okay, because it's so weird and so fun to remember that it will just stick with you, right? Just now, I warn you in public, if someone says, oh man, I don't know how to find the volume of this, and you're like, oh yeah, just like that's stabby, right? That's 1/3 of their blood. People might look at you weird, and they might think that, that something's off. All right. Okay, so that's finding volume. Okay, let's take a look at a different one. So let's say we can use volume. So in another example, so we can use volume to find missing parts. Okay, so we can use volume to find missing parts. So for example, I'm going to do another triangular pyramid. So I'm going to go boom, boom, and then dotted line. So I'm making a right triangle like that, and then I'm making the hypotenuse like this, and then I'm going to go straight up like that. And I'm going to label this, so I'm going to say this is 4 feet. I'm going to say this is 3 feet. And I'm going to say that's the height. And the volume equals 14 feet cubed. So we're going to find the height. Okay. So this would be an example of finding the height of something. Let's say like you just filled it up with water. By filling it up with water, you can figure out the height, which is really cool, right? So like if you have like a really deep hole, you can fill it up with water and be like, okay, I know these are the dimensions of the hole. How deep is it? You can fill it up with water and be like, oh, it's this deep, right? So just by filling it up with water, then you automatically can find the depth, which is a clever way of doing things, right? Okay, as long as you have a way of knowing, right? You have like a measuring cup or something and you're filling it up. Okay, so how do we do this? Well, to do this, we're going to start with the same thing. Okay, can you stab someone with this? Absolutely. So volume is area of the base times the height, and they're going to lose 1/3 of their blood, right? Because it's stabby. So I get volume equals 1/3 of their blood. It's a triangle, so I'm going to have 1/2 base times height, and then the height. So what we're going to do, so we're not solving for volume here. We know volume. So I'm going to go ahead and I'm going to just plug in what I know. I know the volume is 14 feet cubed. I know the base and the height of the triangle. So I have 4 and 3. And I don't know the height. So what we're going to do here is we're going to solve for h. So all this does is it takes a formula that you guys don't have to memorize for the final, right? You guys can just look it up in your notes, and then it makes it so you have to do a little bit of algebra. So it takes it to that next level, right? It takes it to that high school level of doing things. Okay. So we're going to go ahead and do this. Now, what I recommend doing first is just, so you could, see how this is all multiplication? You could just divide by it. And what I mean is that you'd have 14 divided by 1/3 times 1/2 times 4 times 3. Okay, do you see how it's all multiplication? So you just go ahead and divide. And what this does, guys, is it reduces the probability of you making a silly rounding mistake, because rounding mistakes happen and we don't want them to happen, right? So I'm just going to do this all at once. So since it's all multiplication, I can just go ahead and multiply or divide, the opposite. So I take my calculator and I get, on the top I have 14, on the bottom I have 1/3, and then times 1/2, and then times 4, and then times 3. And let's see what we get. I get 7. So then now I have to have the correct units. So 7 what? 7 feet. So my height is 7 feet. All right, how are people doing? Are we okay with that? Do you guys see how I got from my equation to here, right? Since it's all multiplication, I just go ahead and divide, right? I don't have to do it one step at a time. That's just going to make things a lot longer and increase the chance of error, right? The more steps you have, the more likely you are to make a mistake. Does anybody have any questions or anything like that? Because remember, I always build in time for questions. So if you guys have questions, you gotta let me know, right? So we can go over them and do that. All right. Well, if that's the case, then we're gonna keep chug-a-lugging. We're gonna keep chug-a-lugging. Okay. So, I just realized I threw this away and I didn't know. Okay. So let's move on. So I said we're gonna do 11.6 and 11.7. So the only difference here now is we are going to have a cone. So let's take a look at our next example. What example are we on? I think I just lost track. No, oh, it's on this other side. I think I'm on example 3. Doing a bad job of labeling. Okay, so what we're going to do here is we're going to find the volume. But this time, it's going to be a cone. Now remember, it doesn't matter if the cone is slanted, right? It doesn't matter if the cone is slanted. So let's take a look. So in this case, it's going to have, this is going to be 2.2 meters. And the height is going to be 4.5. Okay, that's all the information we get. So copy that down real quick. Okay, so what we're going to do now is we're going to, first, is this a bash or a stab? And I see we have a point. So I'm going to know volume equals, they're going to lose 1/3 of their blood. Okay, but now the base, right? We have to remember that capital B means the area of the base. This is a circle. So when I go to write this down, I'm going to have 1/3, and then the area of a circle is pi r squared. Right, so a circle, and then times the height. Okay, so I'm going to have my volume equals 1/3, and then I have pi. My radius is 2.2 squared, and then my height is 4.5. Okay, and again, no one's asking any questions, so I hope this makes sense and you guys are doing just fine. I'm going to go ahead and type this into my calculator. So I have 1 divided by 3, and I have parentheses, and then we always use the pi button. And I have 2.2 quantity squared. Oops, I squared it twice. Got a little excited there. And then times 4.5. And since we have a pi in it, right, we're going to have to round. So my volume is approximately 22.81 meters cubed. Now, if I wanted to do an exact, you just leave pi out of it. Okay, so you could just leave pi out of it and go 1/3 times 2.2 squared times 4.5, and we could get 7.26 pi meters cubed. Okay, so if you ever want to get an exact, you leave pi out of it and then include it there. Now, that only really works with multiplication. As soon as you do addition, then you're going to have to do some tricky stuff to get that pi out of there. Okay, but for multiplication, you can just multiply, right? All I did here was multiply multiply numbers only. So I did multiply the numbers only. So if you guys want to get the exact answer there, that's what I would do. Okay, so you can do that just by doing the numbers. Again, that only works because this is multiplication. If you try to do that with addition, you're going to have to introduce some more math to get either pi into everything or to get rid of that pi in that first term. Okay. All right. So you guys are doing well. You guys don't have any questions? Right, so a couple of things to be really careful there, right, when we're dealing with pi, right, because pi is irrational, which means it goes on forever, which I feel like some of you feel like my class does. Okay. So let's go ahead and take a look at another example and see where we're at. So I'm going to have you guys try this one on your own. Okay, so let's do this. Let's do have a cone, and then from that cone it is on top of a cylinder. So I'm going to have this height is 4 meters. This height is 5 meters. And this is 6 meters. I want you to find the total volume. So there is a challenge problem for you guys. So this is a composite solid. There are 2 different shapes. I want to see if you guys can find the total volume. So I'm going to give you guys a bit of time to work on this. Not 5 minutes. Let's try 3 minutes. 3 minutes going to be enough? I think 3 minutes is going to be enough. Let's do 3:30. Okay, so you're going to find the total volume. So you have to find the volume of the 2 smaller shapes, right? So I'll help you guys out. There is a cone and there's a cylinder. So let's see if we can put that all together to find the total volume. Make sure you use correct units. Yeah, they fit perfectly on top of each other. So yeah, they'll have the same radius. You can think of it as like this is a firework. Right? So we're trying to figure out how much gunpowder we can put in this bad boy, you know what I'm saying? Yeah. To the moon. All right, so let's go over this. And again, as you guys have questions, just go ahead and ask. So I have two shapes. I have the top shape and the bottom shape. So for the top shape, the first thing I'm going to ask myself is stabby or bashy, right? Is a stab or bash. And the top is very pointed, so that is a stab. So they're going to lose 1/3 of their blood. Now, it's a cone, so it has a circular base. So it's going to be 1/3 pi r squared times the height. So let's see what we have. Now we have to be careful we use the right height. So if we're looking at this top one, the height is 4. So I'm going to have the volume of the cone is going to be 1/3 pi. The radius is going to be the same, so 6 squared, and the height is 4. So I go and type this into my calculator. I'm going to do just the numbers. So if I have 6 squared, right, times 4 divided by 3, I get the volume of the cone is 48 pi meters cubed. So that's my answer as an exact answer. And so how did I get 48? I just went ahead and I did only the numbers, right? So pi, I just left pi there, and I said, I'll deal with that later, right? So I want the exact answer, so I'm not rounding, right? I'm not estimating. I'm keeping an exact answer as long as possible. Okay, then I'm going to go to shape 2. So shape 2 I see is a cylinder. Okay, and then I have to ask myself, is that bashy or stabby? And it's a bash. So the volume of a cylinder is going to be area of the base times the height. So it's going to be pi r squared times the height. So the radius is the same. The height is different, right? This is 5. So I'm going to go 6 squared times 5. So 6 squared times 5. And I get 180. So the volume of the cylinder is 180 pi meters cubed. And so at the end here, I'm going to add these both together. So my volume total is going to be 48 pi plus 180 pi. Now, since they both have pi in them, this is really nice. I can just go ahead and add the numbers, right? So I have 180 plus 48. So I have 228 pi meters cubed is my exact, and my approximate is I just go 228 times pi. And I get is approximately 716.28 meters cubed. So that's my equal, and that's my approximate. So I'm going to just hit pause there for a second. How are you guys doing? How can I help you? Are we doing okay? Where are we at, homie G's? Okay, because I haven't had a single question this whole class. In fact, I don't think I've had a question in a while from you guys besides, are the radii the same? Does anybody have any questions, or is everyone in class just like, Kraft, this is so easy, but we're all just kind of creeped out about the stabby bashy thing that we don't want to ask questions? Is that what's going on? Kraft is creepy. Yeah, exactly. Right? Hide your kids, hide your wife. Mr. Kraft is going to be stabbing people. Yeah, only round at the end. If you round during, then you're going to get something that is called rounding error. And rounding error is multiplicative. So if you round wrong at the very beginning, then that error is going to multiply every step you do. So you got to be really careful. Yeah. So be really careful about that. That's why I always teach get the exact answers, because the exact answers, especially when problems become more complex, right? The further you go in math in life, things get more and more complex. Then you can't be rounding until the end. Okay. So yeah. So well, when I made this lesson, I thought you guys were going to have a lot more questions. People don't would you rather us find the exact answer? You should be able to find both. You should be able to find both. You should be able to find the exact, and you should be able to find the approximate. Now, sometimes we're not going to be able to find the exact. Yeah, so if you're off by 0.1, that means you rounded somewhere, right? So that's why we do the exact. So for volume, it's really easy to find exact, okay? When adding up areas, it's a little bit more difficult to find the exact because you're adding. And but the problems on the final, wink, 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 with volume, you should be able and are expected to find exact answers whenever possible, okay? So that's what I would say about there. You're going to be expected to be able to do both, okay? And just remember, even when you're doing the approximation at the end, right? If you didn't find the exacts before, like one of you guys were saying, right? You're going to be off at the end. So, and it's really easy, right? With round things, all you have to do is just multiply the numbers, not the pi, and just keep the pi there. And just be like, you know what? I don't want to multiply this pi yet, right? I'll multiply that pi at the very end because pi is irrational. Okay. Well, ladies and gentlemen, thank you so much for the great questions. I really appreciate it. That's it for our lesson today. A couple of announcements I do want to make, though. Because we had no school Monday, our schedule is shifting a little bit. So that means that our lesson days are going to be Tuesday, Friday, and our work days are going to be Monday, Thursday for the last 2 weeks. Also, I want you guys to know that your final is going to be on the June 14th. The last day of school is the 15th. So June 14th is when your final is. So June 14th. So I know some of you guys like to plan that out, okay? All right, guys, take care. Have a great day. I will see you Thursday. Bye, everyone.